Hi folks, this time we are going to talk about the equinox. Okay, equa means equal, nox means night. So the equinox occur when there are equal hours of day and night on the equator. For us, further up the side of the ball, that is planet Earth, our night and day are not exactly equal. They're pretty close, but they're not exactly equal on those equinoxes. Equinoxes occur between the two extremes of summer solstice and winter solstice. And the days of those equinoxes are for the spring, or the vernal equinox, somewhere around March 21st, and the autumnal or fall equinox is somewhere around December 21st. Now, from year to year, month to month, this will change a little bit. Some years it's the 21st, some years it's the 20th, some years it's also been the 19th. Why does this vary slightly? Well, mostly because it takes 365 and a quarter days for us to orbit the sun, and that wacky quarter day does affect exactly on our calendar, which is an artificial thing we've created, exactly when those equinoxes occur. In space, it's very predictable. On our calendar, yeah, we just have to flow with it. So in between the extremes of summer and winter, we have those equinoxes. And when you're at equinox, the sun's rays are hitting directly, straight up and down at the equator. So not at a wacky angle, but straight up and down. So if it happens to be March 21st or September 21st, those spring or vernal or autumnal equinox, on the equator, the light's going to hit straight up and down. Those of us who are around 45 degrees latitude, further up the side of the ball, if we take those sun's rays and we bring them next to planet Earth, you're going to see that it's not exactly straight up and down. There is a little bit of an angle involved there, but that's going to be closest to straight up and down for those of us who live at any latitude except for the equator. If you start looking at these equinoxes and you look at both poles, and the North Pole, the sun's rays are going to be on the horizon on the equinox, and at the South Pole, the sun's rays are going to be coming straight from the side, also on the horizon at those equinoxes. Now the solstice, there is the winter solstice, which is right around December 20th. Again, that date will vary because of the whole leap year, extra quarter year to rotate around the sun thing, and summer solstice. Winter solstice is the shortest day of the year. There is the least hours of sunlight for us. The summer solstice is the longest day of the year, and that has the maximum hours of sunlight for us. What happens is this: our sun does not rise or set at exactly the same position on the horizon. During the winter solstice, our sun is going to rise very, very low in the sky, arc across, and that arc is caused by our latitude, arc across the sky and set again. And because our position halfway up the ball of the Earth, that's why we see this weird, crazy arc. All spring, the location of the sun's rising positions is going to get higher and higher. Around the equinoxes, September and March 21st, the sun's going to rise on the horizon a little further north, be up in the sky, and set to the point that the sunrise and sunset, those are going to be pretty equal for day and night. As we approach summer solstice in late June, the position of sunrise is going to be further and further north on the horizon. The sun's going to stay above the horizon a lot more hours and then come back down to Earth, and that's going to give us the maximum hours of daylight. And again, a lot of how many hours of daylight we have, etc., is dependent upon our latitude. The term tropics, and I know somewhere in your past geography lessons you talked about the Tropic of Cancer and the Tropic of Capricorn. These are artificial lines on the globe that have been plotted for years and years and years. And they're at weird numbers. Tropic of Cancer is 23.5 north latitude, and the Tropic of Capricorn is 23.5 south latitude. As the Earth rotates around the sun, revolves around the sun at different times of the year, due to our tilt, we are going to have the sun's rays hit directly above the equator on the equinoxes. Well, the sun's rays, as the sunrise goes higher and higher further north during our summer, at the summer solstice, the sun's rays are going to be straight up and down at the Tropic of Cancer, which is further north. When we get done with June 21st and the days start getting shorter and shorter and shorter due to our path around the sun, the angle at which the sun hits the earth is going to change. And when it's winter solstice, December 21st, the sun's rays are going to be straight up and down above the Tropic of Capricorn. Now, what's the relationship between this weird 23.5 degrees? Let's go back a little bit and see if you can find that number somewhere else. I'm going way back, machine. You guys don't remember the way back machine from the old Mr. Peabody cartoons. Okay, I'm still going back. I should not have gone back. This is becoming difficult here. Okay, this 23.5 degrees, this is the tilt between the Earth's axis and the plane of the ecliptic, that 23.5 degrees. That's what gives us these tropics of Capricorn and Cancer. Those aren't random numbers. The geometry of the Earth is what is producing those. And I apologize for going slow. Here we go. So that 23.5 degrees for those tropics is due to the 23.5 degrees that is right there between the geographic North Pole and that Earth's tilt. The Arctic Circle. Well, the Arctic circles are 66 1/3 degrees north or south latitude. Again, weird number. Where the heck did that come from? Well, remember when we are at the summer solstice, winter solstice, when we're at summer and winter solstice, the highest point above that Tropic of Cancer, the sun is hitting straight on in June 21. And the sun's going to hit straight on at winter solstice, December 21, if you happen to live in the south. Well, if you are way up north near the North Geographic Pole, that means on those days, the sunlight's going to be right on the horizon. Those highest points the sun is going to be and lowest points the sun is going to be for the top and the bottom of the Earth, those give us those Arctic circles. So what that means is during the summer, the sun is so low on the horizon that it never seems to set. And you actually have in the North Pole and the Northern Arctic Circle, you're going to have 6 months of daylight. And in the South Pole, you're going to have also 6 months of daylight, but they are going to be opposite. In the Northern Hemisphere, this is going to be during our summer. And in the Southern Hemisphere, this is going to be during their 6 months of daylight is going to be during our winter. So it all has to do with the geometry of where the sun is coming from. This is a lovely collection of photos taken in Norway, and one photo is taken per hour, and you can see the path of the sun across the sky. The sun rises, arcs across the sky, and then during the night, the sun looks like it's going to try and set, gets low, but never actually sets. So during this 6 months of the midnight sun, which is going to be the summer for the northern hemisphere, the sun travels across the sky, but it's totally visible day and night. This is not the only planet that this occurs on. This is a collection of midnight sun pictures from the planet Mars, and you can see the sun hour after hour crossing Mars, and you can see that arc due to the tilt of Mars's axis. Mars as a planet does not have as an extreme tilt as planet Earth. Now, there's something obscuring the view right here, and that happens to be a huge mountain from Mars that's obscuring the view of the sun, which I think is pretty nifty. So that will end this section, and we will see you later. Bye.